Hello, hello. Now I think it's perfect. Now I think it's perfect. Now audio is clear. Tell me, guys. Now audio is clear. Okay. Thank you so much, Himanshu. Thank you, Ritu. Thank you, Gauravi, Sanjana, Aman, Tatmesh, Shaksham. Okay. Thank you so much, guys. Thank you so much. Okay. So let's continue our session. So guys, in today's session, you may get some questions which is little bit trappy, and some of the questions are directly 1 mark problem, which is generally asked in the gate examination. And I have put it some numerical also, guys, which is basically depending upon 2 mark problem and etc. Right? So you have to give your answer in the chat box first. Then we will discuss what will be the solution for that problem in detail. Okay. So guys, please subscribe our channel, right? Which is basically BYJU'S Exam, Gate and ESC, right? Which is a complete solution to all your gate problems. So guys, this is the first question in front of you. Good afternoon. Come fast, guys. Come fast. This is the first question in front of you. You have to tell me the correct option over here. Like this problem is basically 1 mark problem, guys. So can you tell me what will be the answer for this one? Good afternoon, Teja. Good afternoon, Kumar. Rituraj, good afternoon. Krishna, good afternoon. Vivek, good afternoon. Come fast, guys. Come fast. Okay. Tell me the answer of this particular problem first. The first question in front of you. In limit state of collapse, the partial safety factor for dead load is, for dead load, what should be the value of partial factor of safety? Naresh B, 3 and 4. Okay. Very nice. Harita B. Yes. Yes, guys, the correct answer is B. The correct answer is B. B is the correct answer. Why B is correct answer, sir? We know that, guys, there are some combination which is given by IS 456-2000. But we know that, guys, we are not able to consider dead load individually, right? So you need to make a combination like dead load plus live load, like dead load plus live load plus wind load, right? Or earthquake load. So this particular combination is not possible. Again, guys, if we talk about this one, in this particular combination, the factor of safety is wrong. Basically, it is 1.5 and they have given 1.2. That's why it is wrong. Now, if we talk about third one, that is correct. Yes, if we have dead load plus live load, then we need to put the 1.5 as a partial factor of safety. If you have dead load, live load and wind load, then definitely it should be 1.2. That's why, guys, B is the correct answer for this particular problem. Next question. In the frequency versus strength curve, which value have more frequency? Which particular value will have more frequency? Tell me, guys. Which particular value will have more frequency? Tell me quickly. Which particular value will have more frequency? Target mean strength, characteristic strength, both, or none of this? Yes, it should be target mean strength. We know that, guys, we have a curve like this, which is basically frequency versus strength curve. So you know that, guys, in this particular y-axis, we need to write frequency part, and at the bottom one, we need to write the strength part. So this particular curve is to be like this, right? And this is the value of target mean strength at which the frequency is highest. The frequency is highest. That's why, guys, correct answer is A. The correct answer is A. Next question. The neutral axis by WSM of reinforced beam passes through. Tell me, guys, tell me quickly. The neutral axis by WSM of the reinforced beam passes through. Passes through. Naresh B, very nice. Sanjana B, very nice, guys. Yes, definitely it should be centroid of the transform section. Let us suppose, guys, this one is the singly reinforced beam which is given to us, right? You know that, guys, these are nothing as these are tension reinforcement. Now, first, what you need to do, you need to change this particular cross section area in terms of concrete, right? And you need to neglect the area of concrete which is available in the tension zone. That's why, guys, this particular shape will be like this, right? So just consider this particular axis is our neutral axis, and below that, whatever area of concrete is there, we need to neglect. But you need to convert this particular AST part in terms of concrete, and that's why it will become m time of AST, which is in terms of concrete, m time of AST, which is in terms of concrete. And ultimately, you need to take the moment of area, right? You need to take the moment of area about this neutral axis to find out the value of centroid of the neutral axis of the transform section. So that's why, guys, B is the correct answer. B is the correct answer. Next question. Next question. Be careful. According to IS 456-2000, which of the following criteria is / are not valid for column? Which of the criteria is not valid for the column, guys? Which of the following criteria is not valid for column? Tell me quickly. Which criteria is not valid in column? Tell me, tell me, tell me. Quickly tell me, guys. I shared this video, right? D. Yes, the correct answer is D. Why correct answer is D? Let's understand, guys. The minimum dia which we can provide in as a longitudinal bar in our column, that is basically 12 mm. Yes, it is correct. Yes, it is correct. The statement is correct. The maximum compressive strength in the concrete when it bear axial compression only, right? Then the maximum permissible value of strain will be 0.002. Yes, it is correct. Now, if you want to find out the load carrying capacity of column, then definitely, guys, we need the grade of concrete. What should be the grade of concrete? Grade of steel, cross section area of column, and the dia of longitudinal reinforcement. All these parameters are required to find out the load carrying capacity by the column. And ultimately, guys, if we talk about the last one, which is basically circular column. So, guys, if you have a circular column like this, so in case of circular column, if you are providing the helical reinforcement, then only you need to increase the strength by 5%. Otherwise, if you are providing a circular column and circular tie bars, so you do not have to change the value of load carrying capacity. Do not increase it. It is not recommended by IS 456. That's why, guys, the correct answer will be D, because this statement is not valid and other statements are true, right? Chaitya, I am good. I hope आप भी अच्छे होगे बच्चे, right? Next question. The purpose of reinforcement in the pre-stress concrete is, the purpose of reinforcement in pre-stress concrete. Tell me, guys, the purpose of reinforcement in pre-stress concrete. Cube strength, Abhishek. Tell me quickly. Very nice, guys. Very nice. Superb. All are wrong. The correct answer is C. All are wrong. The correct answer is C, right? C is the correct answer for this particular problem. Guys, listen very carefully. What is the purpose of reinforcement in pre-stress concrete? That we need to understand. Listen carefully. Guys, we know that we have two types of pre-stress concrete member. One is pre-tension, correct? And second one is post-tension member, right? In case of pre-tension member, what you are trying to do, first you need to extend the reinforcement, or you can say that the cables, and after that it will get sufficient strain, tensile strain, right? And after that you have to put the formwork, and ultimately we will put the concrete, right? And we will give sufficient time so that the concrete will set and ultimately gain some strength, and after that we need to cut the cables so that the tension force which is present in the cable will convert it into compression one and ultimately transfer to the concrete, right? Now, guys, in this particular case, no doubt we need the bond strength between the cable as well as concrete, right? But in this particular case, the cable is not resisting the tensile stress. The purpose of this particular cable is only to transfer the tension force as a compression one over the concrete. That's it, right? So that's why guys, our purpose is to impart the initial compressive stress in concrete. But let's understand the post one also, right? Listen carefully. In case of post tension member, let us suppose this is the beam, right? And we have provided some duct over here, right? And inside that particular duct, you need to provide the cable, right? Now guys, tell me, is there any kind of bond between the duct and the cable? No, there is no duct, so there is no bond, right? So you can see guys, by providing the anchoring at this particular location, we are able to extend the cable, and ultimately our task is to transfer the compressive force over the concrete. And you know that guys, there is no bond between the duct and the cable. So that's why guys, this is not the purpose of reinforcement which we are providing in case of pre-stress concrete beam. Clear? So that's why guys, the only purpose is to impart initial compressive stress in concrete. That's why C is the correct answer. Next question. Next question guys, next question. Consider the following statements. Which one is false statement? You have to tell me guys, which particular statement is false? Which particular statement is false? Which particular statement is false? B. Modular ratio depend upon the grade of steel. Okay. B. Yes. You're correct guys. This statement is false. Modular ratio. Modular ratio, we know that guys, M, which is recommended by IS 456, that is basically 280 by 3 sigma CBC, right? This is the value which is recommended by IS 456. Please remember it, right? It is recommended by IS code. Okay. But if you want to write it in general, then you can write it ES by EC. ES by EC, right? ES is what? That is basically Young's modulus of elasticity of steel, which is 2 into 10 raised to power 5. And EC is what? That is basically Young's modulus of elasticity of concrete, 5000 under root of FCK. So this statement is wrong because we know that guys, it depends upon the grade of concrete only, right? So that's why guys, B is the correct answer for this problem. Long-term modular ratio depend upon elastic modulus of steel. Listen guys, if we calculate the long-term value and we calculate the short-term value, let me explain it so that you can understand. Listen carefully. There are two types of modular ratio. One is short-term, one is long-term. What do you mean by short-term? In which the effect of creep is not to be considered. So this particular formula is nothing as the modular ratio which is to be useful in case of short term. But if we talk about guys long-term modular ratio, so long-term modular ratio is nothing as in which we need to consider the effect of creep. So that's why guys, you need to write ECL, right? This value will remain same, which is basically 2 into 10 raised to power 5. But this value, which is Young's modulus of elasticity of concrete, will get changed. And that will become 5000 under root of FCK divided by 1 plus creep coefficient, and you need to multiply this at this particular numerator part ultimately. So you can understand guys, this is nothing as this is basically long term and this is basically short term. In this case, no creep effect, and in this case, full effect of creep. Full effect of creep. So what about this one, sir? What about this one? In this particular case, as per IS 456, they have considered the partial effect of creep. Partial effect of creep. So whenever you are trying to find out the modular ratio for any particular grade of concrete, in case of long term and in case of short term, so the value which you will get as per IS 456, that will be in between those two values, right? Clear? So that's why guys, B is the correct answer for this particular problem. In short term, listen. In short term, we are not considering any kind of effect of creep. But if you talk about IS 456 codal provision, which is means modular ratio, which is given by IS code, then in that case, we have partial effect of creep. Next question guys, next question. the shear reinforcement in reinforced concrete beam is provided to resist what? Is provided to resist what? Tell me guys quickly. Tell me guys quickly. The shear reinforcement, why you are providing the shear reinforcement in RCC beam? D, diagonal tension. Yes, it is correct. We need to take care of diagonal tension. Let me show you that guys. Why we are providing the shear reinforcement. Listen carefully. This is our beam. Let us suppose this one is our neutral axis. Okay. And let us consider this beam is simply supported and we are trying to put the UDL over here. Okay. Now just check it out guys. This one is bending moment diagram, correct? And this one is what? This one is our shear force diagram. So you can understand guys, if I take any element which is present near to the support or at support at this particular location, right? So at that particular point, we will not have any kind of bending stresses, but we have shear stresses. Okay, so let us consider an element which is present at this location. And you know that guys, this particular element is very critical in case of shear because we have maximum shear force at this particular location. That is the reason only, right? Now you can check it out guys. Let us suppose if we taken out this particular element like this, and this is our shear stress. This is our shear stress which is present at this particular location. So what will happen? If you find the resultant of it, so what you will observe guys, this particular value will become like this and this particular value will become like this. Means we will get ultimately the forces like this. So what happened? A diagonal crack is developing. A diagonal crack is developing. This one is what? Diagonal crack. And why it is diagonal crack? Because we have a diagonal tension in this case. What is this? This one is diagonal tension. This one is diagonal tension. Clear? So that's why guys, we need to provide the shear reinforcement so that it can take the diagonal tension. Now let me show you that guys. So generally what we are trying to do, we are trying to provide the shear reinforcement like this so that it can take the diagonal tension part. And ultimately it will be safe in case of shear failure. Clear? So that is the reason guys. So D is the correct answer for this particular problem. Next question. Next. Very simple one. 1 mark question. Very simple. The characteristic load is what? What do you mean by characteristic load? What do you mean by characteristic load? The load which has a probability of 95% of not being exceeded during the life of or design life of the structure. Yes, we can consider that if we are designing any kind of structure. So in case of WSM method, you need to consider the characteristic load as a design load, right? So let me write it down. So if you are using a WSM method, in case of WSM method, the design load is nothing as it is equal to the characteristic load, right? But guys, if you are using LSM method, so in case of LSM method, the design load value will be equal to characteristic load multiplied by partial factor of safety for loads, right? Which is given in the IS 456. And guys, this particular definition of characteristic load is nothing as it is the value of load which has a probability of 95% that it should not be exceeded during the design life of the structure. And that's why guys, B is the correct answer for this problem. Next question. Consider the following statement. You have basically 3 statements for the under reinforced concrete beam. And tell me guys, which particular statements are correct over here? Which of the following statements are correct? In an under reinforced concrete beam, under reinforced concrete beam, Naresh D, none of this. Oh, Oh, Harita C. Okay. 1 and 2 are wrong, but 3 is correct. Okay. Sanjana D. None of this. Okay. Chaksham C. Okay. 1 and 2 are wrong and 3 is correct. Okay. Rahul D. Okay. Gauravi D. Guys, let's understand the question. Okay. So in this particular case, you need to understand which of the following statement are correct for the under reinforced concrete beam, right? We need to consider the under reinforced concrete beam. In case of under reinforced concrete beam, we know that, guys, the value of actual depth of neutral axis is always less than the critical depth of neutral axis, correct? As per this condition, the first statement is wrong. Actual depth of neutral axis is more than the critical depth of neutral axis. That's why this statement is wrong. Now, we know that, guys, in case of under reinforced section, the tension failure will occur. And if tension failure will occur, it means steel will fail first, right? Not concrete. So that's why, guys, second option is also wrong. Concrete reach ultimate stress? No. The steel will reach ultimate stress prior to the concrete, right? In case of under reinforced section. That's why second statement is wrong. Now, if we talk about third one is correct. Why? Because the moment resisting capacity of under reinforced section is lesser than the moment resisting capacity of balanced section. That's why third statement is correct. So C is the correct answer. C is the correct answer. C is the correct answer. Clear? Okay, ji. Next question. Next question. In the pre-tensioning method, which of the following statement are correct? In pre-tensioning method, which of the following statement are correct? Which of the following statement are correct? Tell me, guys. And some 2. Okay. Krishna B, Sanjana B, Naresh B, Vivek B, Ritu B. Okay. Let's understand, guys. Very simple question. In pre-tensioning method, the tension in concrete is induced directly by the external force? No, ji. This statement is wrong. Tension in concrete is induced directly by external force? No. We are not providing the tension force in the concrete, right? Our task is to give the tension force in the cable. Then, as per Newton's third law, equal and opposite reaction will develop. That means the compression force will develop, which is transfer to the concrete. So tension is induced in the tendon before concreting. Yes, it is correct. Concrete continue to be in tension after pre-stressing? No, guys. No. That's why B is the correct answer. B is the correct answer. Next question. Read very carefully. Read very carefully. Read very carefully, guys. Very, very carefully. Which of the following statements are false? Which of the following statements are false? Tell me. Which of the following statements are false? Tell me, guys, quickly. Section B. Okay. You need to tell me the false statement. Okay. Grishma, Babu, Teja, B. Okay. Ritu, Harita, B. Okay. Very nice, guys. Very nice. Let's understand the question. Okay. So as per the first statement, if the characteristic strength be defined as that value below which not more than 50% of test results are expected to fall. That means we are trying to define the characteristic strength and the target mean strength as same, right? So this is the value of target mean strength, and in this case the characteristics definition is also same. So that's why, guys, the FM and FCK value will be same, right? So they are equal. Yes, it is correct statement. In this case they have written then the target mean strength is more than the characteristic strength. This one is wrong. If standard deviation is 0, What it means? We know that guys, in general, the Fm value can be written as Fck plus 1.65 into sigma. If sigma is 0, then ultimately Fck and Fm will be same. So that's why this statement is correct. The relation between target mean strength and characteristic strength is this. Yes, it is also correct. So that's why guys, B is the correct answer. So you can contact me after the lecture, or you can ask me this particular general doubt at the last of the session. I will clear it. No issue. Okay. So B is the correct answer for this particular problem. Right now, if you are enjoying to solve the problem, then go for it. Okay. And if you are able to understand all the topics, then please solve it. Okay. We'll discuss this particular thing, Soumya, right? If the loading on a pre-stress rectangular beam is UDL, the tendon to be provided should be. Tell me guys. Tell me the answer of this one. If the loading on a pre-stress rectangular beam is UDL, the tendon to be provided should be. Some are saying sir B, some are saying C. Yes, it should be B. B is the correct answer for this problem. Let me explain it guys, why it is so. Just imagine this is your simply supported beam on which I am putting a UDL. Okay. So what will be the shape of bending moment diagram? It should be parabolic, correct? And it look like this, right? And the maximum value of bending moment is equal to how much? That will be WL square by 8, correct? Now what happened guys? Whatever shape of bending moment diagram you are getting, just make a mirror image of it so that you can provide the cable as per that condition, right? So the cable should be like this, which is mirror image of BMD, right? Now what you will observe guys, in this case, actually if you observe this particular shape, it is concave from the top view, right? If you are seeing this particular shape, it look like concave, right? But if you observe this particular shape from the bottom, then it is what? Convex, correct? But you need to understand guys, in this case, convexity is upward or downward? It is downward, right? If convexity is upward, it look like this. If convexity downward, it look like this, correct? So that's why guys, B is the correct answer for this problem. Next question. Next question. In a singly reinforced beam, tell me the answer of this one. In a singly reinforced beam, which one is the correct statement? Which one is the correct statement? Which one is the correct statement? Tell me guys. C. Okay, very nice, very nice. C. Yes, C is the correct answer for this problem. We know that guys, in case of singly reinforced beam, the tension is not taken by the concrete, right? But as per this statement, it is entirely taken by the concrete, which is wrong. Steel possesses initial stresses when embedded in the concrete. No guys, after the loading, it may feel some stress, right? Plane section transfers to the center line of the beam before bending remain plane after bending. Yes, it is correct. This statement is correct. And elastic moduli for concrete and steel have different values within the limit of deformation of the beam. No guys, generally within the limit of deformation, the value of ES and EC will almost same, right? That's why the D statement is also wrong. So that's why guys, C is the correct answer for this problem, right? Now let's solve some numericals. First numerical in front of you. Tell me the answer of this one. This is a numerical, right? A reinforced concrete beam is subjected to the following bending moment values. Live load is 30, seismic load is 10. Then you need to calculate the design bending moment value. Calculate the value of design bending moment. B 60, Harita 60, Naresh 60, very good. Teja D, very good. Sanjana B, Gauravi 60, okay, very nice. Very nice guys, very nice. Ritu B, very nice. The answer is none of this. How you can make a combination without having dead load? Guys, in this particular problem, they have not mentioned the dead load. So how you can calculate the design value or design bending moment? Please, please, please remember this particular thing, guys. In your IS 456 2000, what they have given, you need to consider dead load plus live load, or dead load plus wind load or earthquake load. It is also possible. And dead load plus live load plus wind load slash earthquake load. So only these three combination is possible. Other than that, there is no possibility, right? So at least you need the dead load in the combination. Clear or not? That's why D is the correct answer. Clear? Clear? Crystal clear to all of you? Crystal clear to all of you? Okay. Next question. The bond strength can be enhanced when? How you can enhance the bond strength? That is the question. How you can enhance the bond strength? That is the question. How you can enhance the bond strength? Tell me guys, quickly. A. Section A and some A. Okay. Ritu A. Babu A. Okay. 1, 2 and 3. Okay. Let's understand guys, let's understand. If we talk about bond strength, there are two type of value of bond strength. One is permissible value, right, which is given by the IS 456, and second one is developed value. Second one is developed value. Now let's understand both the things over here, right? If we talk about guys permissible value, listen carefully. If we talk about the permissible value, as per IS 456, the standard values which is given in the code is for mild steel, or you can write it, basically it is Fe 250 for tension and for a specific grade of concrete, right? But just imagine guys, if I am using the high grade of concrete, then if you increase the grade of concrete, then this particular value will get increased. Clear? Because the value which is recommended by IS 456, it is increasing as per your grade of concrete, right? So that's why the first statement is correct. Now guys, if we talk about the smaller dia bars which we are trying to use, so this particular parameter will affect over the tau BD permissible. Now if we talk about guys tau BD developed value, because this particular value will change the value for tau BD developed, not permissible. Okay, let's understand it. So how you can write tau BD developed? It is very simple. VU, factored shear force, divided by summation OJD. What is summation O? Sum of perimeter of all the reinforcement, N pi phi, correct? What is J? Lever arm depth factor. What is D? Effective depth. So guys, listen carefully. If you use the smaller dia, without changing the total area of steel which is required for our flexure, right? So in that particular case, if you reduce the dia, then ultimately it will increase the number of bars, so that this summation O value will completely increased, right? If it is increased, so tau BD developed value will get decrease, and if it get decrease, so definitely our task is to reduce the developed bond stress, right? If permissible value will be higher and developed value will be lesser, then our bar is safe in bond, right? Or beam is safe in bond. So that's why guys, second option is also correct. Now if you use the deformed bars, in that case, the permissible value will get increased by 60%. That's why you need to multiply with 1.6 factor. So third statement is also correct, but the fourth one is wrong because in mild steel, the bond strength cannot be enhanced, right? So A is the correct answer. Next question. A is the correct answer. Tell me the answer of this one, guys. Tell me the answer of this one. Tell me the answer of this one. The development length of a deformed reinforcement on compression reinforcement can be expressed as. Tell me, guys. Anu 8, Star B, Teja A, Naresh C. What other student says? Tell me, guys, quickly. Which one is the correct answer? Which one is the correct answer? Tell me, guys, quickly, quickly, quickly. Which one is the correct answer? Tell me. B. Some are saying sir B, some are saying A. No problem, guys. Let's understand the formula first. So first we need to calculate the development length, right? First we need to calculate the development length. How we can calculate development length? It is very simple. LD is equal to how much? LD is equal to 0.87 Fy into phi divided by 4 times tau BD permissible value, right? Now, as per the question, we need to use the deformed bar. We need to use deformed bar. So, if you are using deformed bar, then this particular permissible value will increase by 60%. So, guys, our formula will get changed, which will become 0.87 Fy into phi divided by 4 times 1.6 multiplied by tau BD permissible. Correct? Now, guys, you need to calculate the value of 1 by k, right? Or you can say that the k value directly, right? Not 1 by k. You need to calculate the value of k. So what is the value of k? It is very simple. Acha, Baba, either in this particular case, they have used the compression reinforcement. So we need to increase the value by 25% also. Okay. This is not the tension reinforcement, right? So our value of k will become 4 into 1.6 into 1.25 divided by 0.87. Okay. Just calculate it. You will get the value of k. So we are getting a value of 9.19, correct? So this particular LD value will become Fy into phi divided by 9.19 tau BD permissible. So the value of k is equal to how much? C. C is the correct answer. C is the correct answer. Crystal clear? Crystal clear? Very nice, guys. Next question. Next question. You need to calculate the MR value, movement capacity of the section due to concrete as per LSM method. As per LSM method, what will be the movement of resistance of this particular beam? Guys, I will tell you some standard values also in this particular question so that you can remember it and use it directly in the examination, right? And it is my recommendation, guys, please try to remember the value. We know that we can solve the problem or we can find the values by using the formula. But what happened, guys, if you want to solve the problem quickly or fast, then please try to save some time and try to remember these standard values. Like for M20 and FE415, some of the standard value we have, which we will discuss right now, and You have to remember it. Okay. So tell me the answer of this one. Tell me the answer of this one. The moment capacity of the section due to concrete as per LSM is .44 Naresh. Okay. Teja B, Naresh B, Agna B. Okay. Okay. Krishna B. Very nice, guys. Very nice. So let's understand, guys, what is the formula to calculate the MR value. I think all of you know that, but still let me solve it. MR value, right? In this particular case, they have not mentioned the area of steel and etc. So you do not have to consider anything. Just calculate the value of MR at the limiting condition, right? So MR limiting condition. Q B D square. Now you know that what is B, what is D, correct? So B value is given to us, which is equal to what? 250 mm width. The value of effective depth is also given to us, which is 317 mm. Now what is the value of Q? Q is nothing as that is moment coefficient. Moment coefficient. How you can calculate it? Very simple. 0.36 FCK K into J. Now what is the value of K? K is nothing as that is basically critical neutral axis or limiting neutral axis depth factor, right? So 700 divided by 1100 plus 0.87 Fy. Now what is J? J is nothing as that is basically lever arm depth factor, which you can write 1 minus 0.42 times of K. Okay. Now let's put all the values so that you can get the answer. So what is the value of Fy? It is nothing as 415. Fy is what? 415. So you need to put the value of Fy as 415 over here. So how much you are getting? 700 divided by 1100 plus 0.87 into 415 is equal to how much? 700 divided by 1100 plus 0.87 into 415. So we are getting a value of 0.48, correct? 0.48. Please remember this particular value, which is a standard one. For which combination? M20 and Fe415. M20 and Fe415 combination. You need to remember this particular value. Okay. Now what is the value of J? 1 minus 0.42 into 0.48. So how much you are getting? It is equal to 0.8. Please remember this value also. Now if you put all these two values over here, guys, so 0.36, FCK is 20, K is 0.48 and J is equal to 0.8. So how much we are getting? So we are getting a value of 2.7648. So please remember this one also. Okay. Now let's solve the problem and get the answer. MR limiting is equal to Q is equal to 2.7648 multiplied by B. B is equal to how much? 250. Small d is nothing as 317 square, correct? And then you need to multiply with 10 raised to power minus 6. So that is converted into kilonewton meter, correct? So 2.7648 multiplied by 250 multiplied by 317 square multiplied by 10 raised to power minus 6. So how much you are getting, guys? 69 something, right? 69.458 kilonewton meter, correct? So that's why, guys, C is the correct answer. C is the correct answer. Clear? Next question. Next question. Next question. Next question. Next question. Next question for you. Next question for you, guys. Next question for you. Tell me the answer of this one. Tell me the answer of this one. Just a second, guys. Just a second. I don't know why it get minimize. Oh. Next question, guys. Next question. previous question is B, sir. Wait a second. Yes, the answer is B. Who says C? Tell me, who says C? It is B. आप अच्छे से देखो बच्चों, कहां लिखा है C? बताओ, कहां लिखा है C? कहीं नहीं लिखा. करेक्ट. द आंसर इज B. C नहीं है. Okay, let's solve this one. Let's solve this one. Guys, in this particular problem, you need to calculate the design load as per the LSM for a slab. For a slab, you need to calculate the value of design load, right? Tell me. Okay, Teja. Tell me the answer for this one, guys. Numerical part from part of slab, right? Which particular value is design load as per the LSM method? A slab is given to us whose dimension is 4.5 cross 6 meter, simply supported on all 4 walls, and it carry a characteristic live load of 10 kilonewton per square meter in addition to the dead load. Assume M25, Fe415, thickness of slab being 200 mm and floor finishing is 1 kilonewton per square meter. Tell me the answer for this one, guys. Tell me the answer. Design load, Baba, design load. Design load. Tell me, guys, what will be the answer? Anyone? Sanjana, in this particular problem, they have given the live load also, which is 10 kilonewton per square meter. You need to calculate the dead load value. This is the live load which is given to us. $24. Okay. No issue, guys. Listen carefully. Basically, we need to calculate the loads first. Okay. So in this case, the live load value is already given to us. That is basically 10 kilonewton per meter square. What is the value of floor finishing? That is basically 1 kilonewton per meter square. But the dead load is not given to us directly. We need to calculate it. You know that, guys, what is the unit weight of concrete? That is basically 25 kilonewton per meter cube, right? Per meter cube. Now you know that, guys, we need to calculate the value of dead load per meter square area. That means what? We have an area of 1 by 1. 1 meter by 1 meter. So by which particular value need to multiply this particular factor? That is basically the depth, right? Which is 200 mm. So we need to write 0.2 meter, correct? So if you calculate it, how much you will get? I think 5, right? So 5 kilonewton per meter square. Now add all the values, 10 plus 1 plus 5. How much we are getting? That is basically W. So it is 16, correct? It is 16. 16 kilonewton per meter square. But guys, this is the characteristic value, not the factored values. So you need to multiply the factor, partial factor of safety for load. And in this particular case, we have a combination of dead load plus live load. So ultimately, we need to multiply it by 1.5. 1.5 multiplied by 16. How much you are getting? 24 kilonewton per meter square. B is the correct answer. Khatam. Next question. Next question, guys. Next question. Next question. Next question. Next question. For a simply supported slab of span 12 meter, as per limit state of serviceability, the minimum effective depth required so that it can be safe in deflection criteria. Tell me. The minimum effective depth which is required in this particular case so that it can be safe in deflection criteria. 600. Shahnawaz B. 400. Teja C. Aman A. 600 star. Okay. Guys, you need to remember this particular condition. Okay. Let me explain in detail. Okay. What happened as per IS 456-2000, they have suggested one criteria so that you can at least assume certain value of depth which is required for our beam so that it cannot fail in deflection, right? So as per that particular condition, guys, they have recommended you need to write span by effective depth and it should be less than or equal to A value always. Now what is this A value? A value will depend upon various factors. First, type of support or type of beam, you can say that. Second, the span length. Third, the area of steel which you are providing as a tension reinforcement and the area of steel which you are providing as per compression reinforcement, right? Now let's understand what is in general condition first. So just imagine, guys, if the span of the beam is less than 10 meter, less than or equal to 10 meter, then the A value for simply supported beam is 20, continuous beam 26, cantilever beam 7, correct? But just imagine, guys, if the span will get increased and the span value will become greater than 10 meter, then you need to change the value of A. Means A value need to change, right? So in this particular case, if the span is greater than 10 meter, then there is no modification in this particular cantilever part. But if you have a simply supported or a continuous beam, then in that case, A value should be modified by multiplying it by 10 by span value. Clear? This is first type of modification. Now second modification will depend upon the area of steel which you are providing as a tension reinforcement, and third one is modification factor 2 which is based on compression reinforcement. But for that particular calculation we need the graphs, and ultimately if they are giving the graphs, then you can able to calculate it easily. Okay, so let's come back to the question again. Okay, so guys, in this case the span is greater than 12 meter, correct? So this is the condition which we have right now. So what we have to write? Span is equal to how much? 12 meter. So I am writing 12 meter in terms of mm. So 12,000 mm divided by D, it should be less than or equal to A value. A value is how much? 20. But it should be modified as per our codal provision. So in this case, you need to write 10 by span. So listen carefully, guys. If you are writing the span value over here, it should be in meter, right? So this value is in meter, correct? Now let's calculate 20 into 10 divided by 12. Okay, G. And 12,000 divided by ounce. So we are getting a value of D should be greater than or equal to 720 mm. If the D value is greater than this particular value, then it will be safe in deflection. If it is less than this, fail in deflection. That's why A is the correct answer. A is the correct answer. Next question. Next question. You need to tell me, guys, the minimum and the maximum longitudinal reinforcement for a square column whose size is known to us 30 cross 30 and having a clear cover of 25 mm. Listen, Naresh. This particular criteria is valid for slab as well as for your beam part, right? Next question, guys. Next question. Tell me the answer of this one also. Tell me the answer of this one. Determine the minimum and maximum longitudinal reinforcement for a square column. For a square column, guys, tell me which one is the correct answer. Which one is the correct answer? Tell me. D. Okay, very nice. Let me solve it. So guys, just imagine this is our column in which we have the longitudinal reinforcement like this. These are longitudinal reinforcement. So our task is to calculate what should be the minimum value of longitudinal reinforcement or maximum value, correct? So minimum value, minimum reinforcement is equal to how much? That will be 0.8%. That means 0.8% of overall cross section area. So B into B, that means 300 cross 300. So ultimately how much you are getting, guys? I think it is 720, correct? 720 mm square. Now if we talk about the maximum value of reinforcement. Maximum reinforcement. So maximum reinforcement is nothing as 6% of overall cross section area. 6%. So it is coming around 5400 mm square. That's why D is the correct answer. Clear? Next question. Solid, which is based on pre-stress. An ordinary mild steel bar has been pre-stressed to a working stress value of 200 megapascal. Young's modulus of steel is 200 gigapascal. The permanent negative strain due to shrinkage and creep is 0.0008. How much is the effective stress left in the steel? Tell me. What will be the value of effective stress which is left in the steel? Tell me, guys. C, 40. Okay, G. Very simple question, I think so, right? So you can see here, guys, the working stress value is given to us, right, which is basically 200 megapascal, and the Young's modulus of elasticity is given to us, which is basically 200 gigapascal. So first we need to calculate how much is the loss of pre-stress is there. So how we can calculate it? The loss of strain multiplied by ES value, correct? So how much loss of strain will be there? 0.0008 multiplied by 200 gigapascal. So 200 into 10 raised to power 3. So that is converted into megapascal. Let's calculate this value. I think it is 160. Yes, we are getting a value of 160 megapascal as a loss of pre-stress. And how much is the pre-stress which is initially present? That is basically 200. So from 200, 160 is lost. So what will be the net value? 200 minus 160, it is 40 megapascal. So C is the correct answer. Next question. For a rectangular beam of width B, overall depth D, effective depth D, the maximum spacing of vertical shear reinforcement shall be vertical shear reinforcement. D. Yes, D is the correct answer. 0.75 D or 300 mm, whichever is less. Right? So this particular value is valid for vertical shear reinforcement. Like this one. Right? And if you are having an inclined shear reinforcement, in that case, just imagine this is inclined shear reinforcement. So for inclined shear reinforcement, the value will become D or 300 mm, whichever is less. Right? That's why D is the correct answer. Next question, guys. Next question. Now listen carefully, guys. Listen carefully. This particular problem is MSQ. MSQ means multiple option can be correct. Multiple option can be correct. Multiple option can be correct. You need to solve the problem first, okay? Then only you will get the answer. So kindly solve it and let me know the answer. Quickly, do it. MSQ. MSQ. Previous is A. Rituraj, the answer is D, not A. How it is possible? The answer is D, not A. Solve it, guys. Solve it quickly. Jaldi karo. A and C. Very nice, Teja. Very nice. Good. Arman, good. Grishma, good. Anu, good. Yes, A and C are the correct answer. Now listen, guys, this problem is very simple. Just you need to calculate the values over here. So this is the beam which is given to us. Just consider this is the beam which is given to us. This is the beam which is given to us. Okay. And the cross section is also known to us, right? So let me draw it. The cross section is also known to us, which is basically 120 to 200. Okay. Now, if we are trying to pre-stress it with an eccentricity of 20 mm with respect to the centroidal axis, right? So this is our pre-stressing force which have certain eccentricity, which is given to us 20 mm. And this pre-stressing force is equal to how much? 150 kilonewton. Now tell me, guys, If you're trying to pre-stress it, so there are two type of stresses which come over here, right? One is direct, which is P by A, and both will be positive, right? Because it is compression. And second is bending. Bending stress due to pre-stressing force. At the top, you may find tension, and at the bottom, you may find the compression. So this one is negative, this one is positive, and this will be PEY by I, correct? Now what is our task? Our task is to calculate the top value and the bottom value. Now listen carefully, guys. Listen carefully. I will not calculate the value, but I will put the answer directly. How? Let me show you that. Guys, we have basically 4 statements, and 2 statements are opposite to each other and 2 statements are opposite to each other. So definitely if it is MSQ, then definitely guys, one of these is to be correct. Now just check it out. At the top value, we will have a positive and a negative value. Then definitely the value will be lesser at the top. But at the bottom, you have a positive and positive. That means at the bottom, we have a greater value. So at bottom fiber, you may find the value of stress is higher. So guys, that's why A is the correct answer. A is the correct answer. Why? As per B statement, the stress at the top fiber is higher as compared to bottom one. That's why this statement is wrong. Clear? Now if we talk about the C statement, if tendon passes through the central axis, then the stress at the top and bottom fiber will be same. Yes, it is correct. Guys, if we do not provide any kind of eccentricity, then this particular part of stress will not be there. It will not be there, right? This particular part will not be there. Only this particular portion of stress will be valid. That means at the top and at the bottom, you may find the same value. That's why C is also correct. C is also correct. D is wrong. Clear? So A and C are correct. Without solving problem, we can solve the problem also, but you need to do the smart work. You need to do the smart work. Next question. If you want to calculate it, guys, you can calculate it by putting the values directly. Okay, I have told you the formula. Next question. Next question. Next question, guys. Tell me the answer of this one. The minimum stress on the beam subjected to a maximum bending moment is? Yes, it is CR. C. We have already discussed the condition over here. You can see here, guys. This is what? चलो इसको ऐसे देख लेते हैं. Okay, just check it out like this one. So we need to calculate the minimum stress on the beam subjected to the maximum bending moment is. Okay. So guys, you can see here what is PE, that is basically moment. Okay. So you can see here, guys, at the top you may find P by A minus, instead of writing P into E, you can write M also, My by I. So I by Y is what? Z. So you can write Z and remove it. So ultimately this is the minimum stress which can occur. And that's why, guys, C is the correct answer. C is the correct. All of you are able to understand or not? Tell me, guys. Tell me. All of you are able to understand this concept or not, guys? How to solve the problem quickly? You can apply the logic directly, right? Okay. Soon it will be there. जल्दी होगा जी, आपको मिल जाएगा भी कुछ दिन में. Okay. Again, I will take one more session, which is basically environment itself. So day after tomorrow, we have an environment, marathon for environment. Next question, guys, next question. If the tendon is placed at an eccentricity of E below the centroidal axis of longitudinal axis of a rectangular beam, the stress at the extreme top edge . Structure, I think after that, after environment, we have a structure part. C. Yes, you can see here, guys, we have discussed at the top fiber. at the top fiber, the value of stress is how much? That is basically P by A minus PEY by I, correct? So due to this particular value of stress, our net value will get decrease, not increase, right? So you can write this particular value in this way also, PE by Z. So due to this, the value is decreased. C is the correct answer. Next question. Next question. If the area of maximum mid-span movement is 205 mm, what would be the area required for the corner reinforcement at both edge continuous? When you have both edge as a continuous, then what should be the area of corner reinforcement or torsion reinforcement? Tell me guys. A. Okay, man. Any other student? Any other student can tell me the answer? Abhishek, C. Anu, A. The correct answer is C. Why C? Let me explain it. Guys, this end is what? Continuous edge. This one is continuous edge. This one is discontinuous, continuous, discontinuous, 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 continuous. When you have both edge discontinuous, then you need to provide the torsion reinforcement. One edge discontinuous, other is continuous, then again you need to provide the torsion reinforcement. But if you have both edge continuous, no need to provide torsion reinforcement. No need to provide torsion reinforcement. That's why the answer is C. The answer is C. Clear? The answer is C. Next question. Next question, guys. Next question. Now these are the questions which is based on IS 456 codal provision mainly, right? So tell me the answer of this one quickly, quickly. Rectangular and parabolic. Rectangular and parabolic. Yes, it is correct. You know that, guys, the shape is to be like this. For stress versus strain diagram, the shape is like this, right? So partially it is rectangular and partially it is parabolic. So this one is rectangular and this one is parabolic, correct? So C is the correct answer. Next question. In limit state design, the limiting value of depth of neutral axis is. Tell me the answer of this one. Quickly, guys, quickly, which is based on IS 456 2000 codal provision only. In limit state design, the limiting value of depth of neutral axis is. Yes, it should be 0.48 D. We know that, guys, XU limiting for M20 Fe415, we can use K into D. So what is the value of K? It should be 0.48 times of D. Next question. Deflection can be controlled by using the appropriate. How you can control the deflection? C. Span by effective depth ratio. Span by effective depth ratio. Next question. The final deflection due to all loads including the effect of temperature, creep, shrinkage and measured from as cast level of support of floor, roof and all other horizontal members should not exceed. Guys, just remember this particular single word, right? The final deflection value. It should be span by 250. Right? If the final word is there, you need to tick span by 250. Okay. If final word is not there, then the value will become how much? Span by 350. Correct? Modular ratio. Tell me guys, all these questions are 1 mark problem, right? Now these questions are 1 mark problem. 1 mark problem based on codal provision. Modular ratio. C. 280 by 3 sigma CBC. 280 by 3 sigma CBC. Characteristic strength of cube for concrete. Tell me. Characteristic strength of concrete is measured. B. 28 days. After 20 days, that means the characteristic strength of cube is FCK, but the characteristic strength of structure is 0.67 FCK. Next, the minimum grade of RCC in seawater. The minimum grade of RCC in seawater. M30, M15, M20, M40. M30, minimum grade is M30. Minimum grade is M30. Next question. Minimum grade is M30. The value of ultimate creep coefficient for concrete, that means theta C, and age of loading is 7 days, 28 days, 1 year. B, decrease with age of loading. Okay, this is 2.2, 1.6, 1.1. So you can see here guys, this value is decreasing and this value is increasing. As we move downward, this value is increased, this value is decreased. That's why B is the correct answer. Next question. The characteristic strength of concrete is defined as the strength below which not less than dash of the test result are expected to fall. Some are saying B, some are saying A. The characteristic strength of concrete is defined as the strength below which not more than 5% of test results are expected to fall. But in this case, they are using which is not less than. So you need to write 95%, right? The answer is 95%, not 5%. Guys, if we use a statement like this, the characteristic strength of concrete is defined as the strength below which not more than 5% of test results are expected to fall. But 95% of test results are greater than that particular value. That's why this answer is A. Next, in the actual structure, what should be the characteristic strength? Abhi bataya. The characteristic strength of concrete in the actual structure. Tell me guys, tell me. C, 0.67 FCK. This one is what? This one is our characteristic strength for cube. What is this one? This one is characteristic strength of, this is the characteristic strength of actual structure, right? And guys, if you use partial factor of safety, then the curve will become like this, right? And this is nothing as uncertainty factor. So this value will become 0.67 divided by 1.5 FCK. Clear? So C is the correct answer. Next question. Modulus of rupture of concrete gives. Modulus of rupture of concrete gives what? C, the tensile strength of concrete under bending, and the value will be 0.7 FCK under root of. The value will be 0.7 under root of FCK. Clear? C is the correct answer. Next question. As per IS 456-2000, the organic content of water used for making concrete should not be more than. How much organic content can be allowed in the water which is to be used for concrete making? Yes, it should be 200 milligram per liter. 200 milligram per liter. It should not be more than this, right? Guys, this is the table which you can see here, and as per the condition which is given by IS 456, what they have suggested, if you are using a water in which organic concentration is there, then it should not be more than 200 milligram per liter, right? Next, in the absence of test data, the approximate value for total shrinkage strain for design may be taken as how much? May be taken as how much? Tell me guys quickly. If the data is not given, then how much total shrinkage strain you will consider for designing purpose? Arre D Baba, 0.0003. 0.0003. Correct? This is the statement which is written in the IS 456 codal provision itself. Okay. So you can see guys, this statement is like this. As it is, which is given in the code, right? Limit state of serviceability of pre-stressed concrete section should satisfy what? Limit state of serviceability. Serviceability. Please be careful. Limit state of serviceability of pre-stressed concrete section should satisfy what? Guys, serviceability means what? The problem which may occur during the service. When we are trying to put the load at the service duration, so that means whatever problem you are facing, that you need to consider in LSM of serviceability. Yes, it should be deflection and cracking. Deflection and cracking. Next question. Minimum allowable percentage of tension reinforcement in RCC beam is minimum. PT minimum value. उड़ा दो बच्चों. PT minimum value. Tell me guys. Yes, A is the correct answer. The PT minimum value, which means percentage, minimum percentage tension reinforcement, which we needed, 0.85 into 100 divided by Fy. Next question. Next question. In bending, the maximum strain in the concrete at the outermost compression fiber is taken as how much? All these questions are 1 mark problem, which is IS 456 codal provision problems. Maximum strain at the outermost fiber. Yes, it should be 0.0035. And at this level, we have Fy divided by 1.15 ES plus 0.002, right? This is for concrete, this is for steel. That's why C is the correct answer. Next question. Next question. In design of RCC structure, the tensile strength of concrete is taken as how much? In design of RCC structure, the tensile strength of concrete is taken as how much? Tell me guys. Very nice, very nice. Tell me guys. How you can say that it should be 5? How you can say that it should be 2? How you can say that it is 0.3? None of this. None of this, because the value will be 0.7 under root of FCK. D is the correct answer. Next question. What is the target mean strength? What is the target mean strength for M30 grade concrete? What is the target mean strength? FM value is equal to how much? FCK plus 1.65 into sigma. Now tell me guys, what will be the answer for this problem? 38.25. FCK is equal to how much? 30. 1.65 multiplied by sigma. Sigma is equal to how much? 5. So how much you are getting? 38.25. C is the correct answer for this problem. उड़ा दिया बच्चों, बहुत बढ़िया. Next question. Which of the following structure load are not applied commonly to a building? Which particular type of load is not commonly applied to a building? B. Rain load. Rain load. Rain load is not to be considered. Rain load is not to be considered. Rain load is not to be considered, right? Next question. What is the meaning of the designation M30 concrete suggested for a reinforced cement concrete work? Tell me the answer of this one, guys. Vivek C. The mixed characteristic compressive strength of 150 mm size of cube at 28 days is 30 Newton per mm square. Very good. C is the correct answer, guys, which is a very simple question, right? Next question. The diagonal tension reinforcement is provided as what? How you can provide the diagonal tension reinforcement? How you can provide the diagonal tension reinforcement? Tell me. Bent up bar. Bent up bar is the form of shear reinforcement. It is all the form of shear reinforcement. Shear reinforcement. Next question. In an RCC section of effective depth D, if inclined stirrup are provided to resist the shear, their maximum spacing measured along the axis of the member as per IS 456 should not exceed. Already discussed. Tell me, guys. D or 300 mm, whichever is lower. Clear? Next question. उड़ा दो बच्चों. The design shear stress in RCC depend upon what? The design shear stress in RCC depend upon what? Please be careful. You need to tell me, guys, design shear stress value. D. Okay. Let me explain it. Guys, do you remember the tau C value, which is nothing as shear strength of concrete? Shear strength of concrete without shear reinforcement. And this value will depend upon percentage of tension reinforcement which you have provided. And the second one is the grade of concrete, right? Which grade of concrete you are using? Grade of concrete. Which grade of concrete you are using? That's why A and B are correct answer. C is wrong. D is the correct answer. उड़ा दिया बच्चों, बहुत शानदार. The bond strength of concrete increase with what? Tell me. C. The grade of concrete. Already discussed this particular point in the previous question also, right? C is the correct answer, right? C is the correct answer. The bond strength of concrete increase with grade of concrete. But what about the tensile strength of steel? It will depend upon that also or not? It will depend upon that also or not? Yes, because if we have mild steel, And if we have HYSD bar, so in case of HYSD bar, the value will get increased. So tell me guys, which of the following statement, which of the following option can be correct? Tell me. The answer should be B and C. But listen carefully, guys. Just imagine if this particular problem is MCQ. So what you need to do? You need to take the grade of concrete only. Listen carefully, right? Because the primary is grade of concrete. But the special condition will be there. When you have a MSQ problem, right? When you have MSQ problem, then you need to take answer as B and C both. For this one, the answer is C. Clear? That's it. That's it, guys. That's it. That's it. So tell me, how's this session? Maza aaya? So guys, listen. We'll meet again day after tomorrow with environmental engineering. Okay. So you will love that particular session also. Again, we have a marathon for environmental engineering, right? So day after tomorrow, we will meet again, guys, and we will discuss the different problems from environment part. But do not forget, guys, to hit the like button. Please hit the like button as well as share the session to other students also, right? And one more thing, guys, in environmental engineering, we'll discuss a lot of numerical also and the theoretical problem, right? And if you find any kind of doubt over there, I will explain it. No issue, right? Chaliye. No, listen, guys, listen. Tomorrow, there is no structure part. Day after tomorrow, we have the environmental engineering part, and then after that, we have structure. Okay. Listen carefully, guys. Tomorrow, there is no session from my side, right? But day after tomorrow, we have the environmental engineering, and after that, we have structure part. Okay. Chaliye ji. So thank you so much for joining the session. I hope you are enjoying the session, right? Okay. Chaliye ji. So this is all about for today, guys, from my side. Let's close the lecture and we'll meet day after tomorrow, right? Bye-bye. Take care, guys. Thank you, guys. Thank you so much. Thank you so much. So I'm closing the lecture, guys. Okay. We'll meet soon.